Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by HipChat. Collaborate, save time, and be more productive with your teams. HipChat is IM video chat plus file, code, and screen sharing all in one place. Invite your team members and get a free 30-day trial of the full version of HipChat at hipchat.com/C101. And by Squarespace. Squarespace is the easiest way to create a beautiful website, blog, or online store for you and your ideas. Go to squarespace.com and enter the offer code C101 at checkout to get 10% off. Today on Coding 101, we continue our Arduino Steam clock with Smitty. Let's get coding. Hello and welcome to Coding 101. It's the Twitch show where we let you into the wonderful world of the Code Monkey / Code Warrior. I'm Father Robert Ballas, the digital Jesuit, and with me today is super special guest co-host Lou Maresca. That's right, Lou Maresca, a senior software lead from Microsoft. Lou, it's great to have you back. Thanks for coming back on the show.
Thanks for having me back. Appreciate it.
Now, Lou, before we get into this wonderful Arduino crossover that we're doing with Coding 101 and know-how, I thought it would be very important to talk about an idea that is central to the code that goes into the time library. When I was speaking with Mark Smith, he talked about using a library to get information from the real-time clock. And in doing that, he took it in something called a structure. What is a structure?
So I think, Joe Heck on the Google Plus community for Coding 101, he had a really good post on this. So I urge you to go check it out. But one thing that he said, and the way he explained it was, a structure is a record, right? It's containing one or more pieces of data that are grouped together. That's a quote from his. And that's really exactly what it is. It's a record that, like I like to think of it like a book that keeps track of its attributes, like its title and its author and its subject and its book ID. And that's really how you kind of describe that record. And you can describe, you can actually define a structure in languages like C++, C, C#, that represents that record and all of its attributes. And you can kind of define that. And then you can add the data to it. And the data can be really any type.
Right. Now, there's going to be people who say, wait a minute, why can't I just have variables? I have variables, right? I already know how to do that. Why do I need a new structure in order to hold all those variables together?
So, like, structure in many languages are very similar to, like, we talked before about, like, classes and objects. And so, like, the way that structure works is basically allows you to define and describe something so that it's reusable in many different ways. And so that's really kind of like, and structures and classes are kind of identical in a way in many different languages. And like many people use the word class to kind of define both of them. But when you actually define a class, you can create an instance of that. And then you can kind of use different instances. Like, for instance, I create a class called book, and then I have its attribute called title and its author and its number. And then I can create many different instances of those books and have many different titles, many different authors, and then I can store that somewhere, like if I wanted to store it in a list or some collection, and then I can go and retrieve that information from memory in your application. So it's really just a way to classify what you're actually trying to do. It's a way to describe your intentions when you're building an application.
Right, and actually that would be the second question I would have for you, which is, we've already talked about structures and how we use classes. And it seems to me that there's a lot of similarities. This idea of grouping together similar objects, similar pieces of data, similar functions into one place so that I can declare it multiple times. So I guess someone who went through the C# module, the second one, and learned all about classes, they'd be asking, wait a minute, can I do everything in a class that I would do in a structure?
Yeah, so structure is kind of like a subset of what, so classes are like supersets of substructures, I like to think of that, because structures are, everything you define in a structure is normally what we call public. So like, for instance, if you define a title or author, it's public. It's public information. So when you go and try to use an instance of that, book structure and create an instance of it, you can access the title and author. Classes are kind of like a way to, you can create a class. It's identical to kind of to a structure, but allows you to kind of define other things in the class. Like, for instance, accessibility and other things where you can privatize things and not have it accessible from externally. So if you wanted to, like, under the covers, maybe change the language of the title when, localization wise, under the covers, if it's, depending on what machine language they have. So if they have like Chinese on their computer, it would, it'd turn into Mandarin or whatever. So, I mean, there's different ways to do that, and classes can do that in private methods or functions. So structures, everything's kind of public in a way. So that's kind of how they're similar. But depending on what language you're using, like C and C++, they're very similar. But for instance, in a language like C#, a structure is stored differently in its memory structure because it's C# is built on top of a runtime, and we go all into that into the C# module. So check that out. But again, they're pretty much similar. It's just that they're the way that they kind of declare their stuff is a little different.
Right, exactly. And I remember that structures, at least in C#, are always stored contiguously, right? So you're going to have all those bits and pieces of data that are associated with each other next to each other in contiguous memory blocks. Now, here's something else I'd like to know. When we did Santa's Little Helper, again, if you go back a couple of modules to the last C# one, we talked about using this JSON blob, this idea that we would get a bunch of information and then somehow we had to parse it out. Well, it seems to me that if we had a way to pull a structure rather than a JSON blob, we wouldn't have to go through the process of parsing because it comes pre-parsed.
Right. So, I mean, the way that you could kind of define a structure, again, is very similar to a class. And you basically declaring your intentions of what that's supposed to look like. And I guess JSON is just kind of the same way. It's a text format or a string format of your actually in-memory version. So, like, for instance, if I had a JSON blob that had a JSON blob of books and it has different attributes in it or properties, it would define, a book and its type or whatever, and that's a big long string. So you would store it in, a piece of memory, and it would become in one long stream. But with a structure, you can define, an actual object that, defines each property, each attribute. And again, like you said, it's stored in a continuous block of memory. So if I ever did like the actual size of that object, I'd be able to tell what it is. And again, I'm defining exactly what it is. The compiler can say, okay, this is a book, and it's got an author and a title, and it can define, if I try to store like a number within like the title, it'll say, no, you can't store a number in the title unless it's a string, that kind of thing. So it creates a way for you to describe your intentions when you're building your application.
When I was learning C++ way back when, one of the differentiating pieces of data that I took was that I would use structures whenever I needed to separate certain records, data records. But as we move into object-oriented programming, I can have structures that contain data and behaviors as well, which, again, I'm going to go back to this. I know you answered this, but I want a clearer answer for the people who are going to struggle with this as they start to look at structures versus classes. And that, again, is where do you use a structure and when do you use a class? If I can have a structure that basically acts like a class, because it's not just handling data, but behaviors, then why do I need a structure? And vice versa. If I have a structure that contains data and behaviors, or a class that contains data and behaviors, why do I need a structure?
So that's a good question. So classes allow you to do a lot of other things that normally structures don't do. So, like, for instance, you can create, you can actually, like I said, you can hide things in them. You can create different versions. You create inheritance structures where you can have many different versions of it. So you can have a book, but then you can have like another version of that where you can create like a large format book or maybe a Kindle book, that kind of thing. And so you can create different versions of that using classes. Structures are really kind of basically defined for small little things. Like, for instance, if you're doing something in an application that might require you to store small pieces of data or small, like you said, small functions or methods, then that's where when people use structures, because they're very easy to define. Again, that they're a continuous block of memory, so you're not going to fragment your memory. And so it's very easy to use, and they're really made to just do very small things. Now, classes, on the other hand, are made to do potentially a lot of different things. So, like, you can have a class that might be a book, but then you have another class that like is made to sort the books and do other things, right? And so they're made to do more functionality, and they're a little easier to define. You can define again things under the covers as well as above the covers. So it's kind of like, I like to think of it like this: if you have let's say like this audio receiver, and on the outside you have a bunch of dials and controls. But on the inside of the receiver, there's all these different components, electronic components. So a class can define those internal components and the dials on the outside. But a structure is really, there's no internal stuff. It's just the outside. So it's just a black box. And you see all the outside, you can define all the dials and controls, but there's no internal stuff. There's nothing hidden. So with a class, you can hide a whole bunch of stuff, and you can hide a whole bunch of implementation and a bunch of details that you don't want somebody who's like they were saying, that you could use a class and use different libraries. And what it does, you can hide a bunch of things under the covers that it actually does. So if you want to talk to hardware, you can hide all the hardware code and just have an interface for people to say, send signal or send a beep, that kind of thing. Very simple things. So that's really kind of hiding things with classes. Structures are more smaller function and very clear, concise function.
Yeah, absolutely. Well, thanks, Lou. Now, if you want to know a bit more, I actually, like Lou, I would suggest you go to our Google Plus group, look for Joe Heck's post. I believe that was last November, because he does a really good job of explaining why he would use a structure, what it is, and how it works. Again, Joe Heck's a member of our community, really good guy. We've been trying to get him on the show, but he doesn't answer emails. Joe, if you're listening, reach out, because you're actually quite a good teacher, and we want you on Coding 101. Lou, when we come back, we're going to be going into our Arduino clock build. That's right, this is episode 3 of 4. We're almost there. We're starting to put everything together. In the last 2 episodes, we explained what an Arduino was, what embedded programming was. We showed you how it worked, how you could do Hello World, and how you could get information off of the real-time clock. Now we're going to start moving into how you actually put the bits and pieces together and get the right inputs to the right outputs after being processed by our software. Are you interested in all that, seeing that, Lou?
Absolutely.
All right.
Looking forward to it.
But before we do that, can we take just a moment to thank the first sponsor of Coding 101? Now, let me ask you a question. How do you communicate? I know that's a silly question in this day and age, because we've got so many different tools to communicate. It's not just the phone and email and text, but there's every kind of social platform, both personal and business oriented, that gives you so many different options, from video and voice to text to screen sharing to data sharing, that it's one of these questions that people don't often ask. But let me ask you, how do you communicate effectively? Here in the Brick House, we use HipChat by Atlassian. Now, HipChat is a way for your team to use email, IM, texting, cloud storage, document sharing apps all in one place, and it's been specifically designed for business. HipChat is IM, video chat, all those things in one easy to find place, so that your team never gets confused about what tool they should be working on, about what was said when. HipChat is sort of like memory for your communications, and that's just something good to have in business. Email is too slow, meetings get sidetracked, and regular IM doesn't really work well for groups. But HipChat keeps your team in sync, and it works from any device, no matter where you are. Best part, and this is important for developers, HipChat integrates with the top developer tools like GitHub, Jira, Zendesk, and more. You can check out the 57 services that HipChat plays nice with. HipChat brings your entire project and team communications together. I know, if you're not a developer, that may not sound like a big thing, but if you've ever developed code in a team, if you can tie changes and revisions that are made in your code base to the communications that actually led to those changes and revisions, it's invaluable. It's gold, folks. HipChat is easy to use, it's fun, and it makes your team wildly productive. We have used HipChat here. It's how we communicate in the Brick House. And I've actually used it with a couple of my development teams. And I got to tell you, it changes the way that you communicate, and it changes the way that you work. And really, that's what we want out of our communications tools. Now, get your team on the same page in seconds today. There's a freemium version that you can use free forever. But for the next 30 days, you'll get the full version of HipChat, which includes the bonus features of video and screen sharing. You can try HipChat free. No credit card required. Visit hipchat.com/C101. Sign up by clicking on the Start Chatting button, then invite a few team members and try it free for 30 days. And for the first 100 signups, HipChat is going to extend their 30-day free offer to 90 days. Remember, that's hipchat.com/C101. 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 HipChat, your team, your project, in sync, instantly. And we thank HipChat for their support of Coding 101. Well, let's get right to it. We've got our code warrior, Smitty, Mark Smith, back, and he's going to give us a little Arduino action. We'd like to welcome back our code warrior, Mr. Mark Smith, again, Smitty from DEF CON. Now, when we last left this project, Smitty, we had just assembled the shield on top of the Arduino. We had added the real-time clock, added the library so that we could get the data from the real-time clock, and you showed us a very simple program that took that data, parsed it out so that we could just get hours, minutes, and seconds.
Correct.
Now, of course, we want to end up with something like this, so although that's nice that we could get the time out of the real-time clock, eventually we're going to have to push that to the outside world. Going back to the first module, we have our inputs, now we need to figure out our outputs.
Before that, though, we also need to make sure that the time is correct.
Let's
true.
do that.
Yeah,
Yes.
they don't actually set the time on the modules when they leave the factory, and if they did, you don't know what time zone you're in, blah, 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 blah. It's not correct. You got to set it, right? So what we're going to do first is we're going to hook up some buttons to our Arduino and tell it what time it is.
Yeah.
So I have a button here. I think it's the same button that we looked at last week, and I am going to just put this on the breadboard. Put the button on the breadboard there, and we'll go ahead and do the other two while we're at it, just because. There's the third one, and like so. Now we need to hook those buttons up to the Arduino. So I'm going to take some of these wires, these hookup wires that we have, and I'm going to take one side of this button, and I'm going to connect it to one of the digital inputs. But before we do that, let's look at which inputs we're going to use. Now remember, last week or the week before, we were talking about the PWM outputs or digital I/O lines, and the ones that can do PWM, the analog outputs, and the ones that can't. For buttons, we don't want to take one of the PWM lines because we're going to use those for the analog meters. So we're going to use the lines that cannot do PWM. So I'm going to start with 2, 4, and 7. So I'm going to put the shield back on top. And I'm going to hook up the wire between 0, 1, and 2, right there. Then I'm going to take that wire from another button. That's 2, 3, 4, what did I say? 4? Yeah, 4 and 7. 4, and then we'll take the third button, push it back on the breadboard. From there to 7, which is the last one on that block. So I've hooked up those 3 wires, there we go, to their digital inputs. Now I got to hook up the other side of the buttons to somewhere, and we're going to use ground on the other side. So the buttons, when you push them, will connect that digital I/O pin to ground. And this big block of connectors up here, all 10 of these are ground, so I can just plug into any one of them. It doesn't matter which one. So now I've got 3 buttons hooked up to the 3 different inputs, and they will connect to ground when you push that button.
Right.
Normally, you would also hook up a resistor between the positive side, the blue wire here, and the positive 5 voltage, or the plus voltage over here. It's called a pull-up resistor, so that when the button is not connected, the inputs to the Arduino will see a high voltage instead of just a disconnected voltage with no voltage at all. It's called a pull-up resistor. The Arduino can do internal pull-ups, so we are not going to bother with that. And then we'll see in the code where we turn on the internal pull-ups so that we don't have to worry about blah, blah, blah.
All right, so that's the hardware. That will give us ground whenever we push the buttons. But now we need to do something inside the sketch in order to actually get that in.
Correct.
All right, let's
go look at that. So this is a updated version of the sketch that we looked at last week. You'll see the same pound includes and some of the same pound defines, although I think I changed the name. I added pin in front of it, so just
it's more descriptive.
More descriptive, exactly. But I added a couple of new ones, button minute and button hour, and we chose pins 2 and 4 for those. So those are the buttons that we used, the digital inputs that we used to connect up those buttons, right? So we have a couple more pound defines. I am defining a few variables here. These are globally defined variables, which means they will be available in both the setup function and the loop function. If we defined them inside either setup or loop,
You could only use it inside
that particular function, exactly. So by defining them outside of those functions, they are globally available. You can be anywhere. If you're writing normal software that's not in an embedded environment, you generally want to avoid globally scoped variables.
Global variable. Wait a minute. No, global variables are evil. What?
Yeah.
But we're using it here for ease of programming.
Well, for ease of programming, and because the scope is a few, less than 100 lines of code, right?
Right.
We can keep track of the scope of all of this stuff in our head. It's a small enough program we can get away with that.
Exactly.
So right here we are doing very similar. There's the power up of the RTC, which we saw last week. So we're providing power to the real-time clock. Then we are configuring the buttons that we just hooked up. So we're saying button minute and button hour are inputs. So we are going to be reading data from those pins. And so we set that in the pin mode. Then digital write. So we are writing to an input pin, which seems somewhat counterintuitive. But this is how you enable the pull-up resistors. So this is a ATmega feature. If you write a high value to an input pin, that will enable the input, the internal pull-up resistors.
Right. So in other words, if it doesn't see anything, it doesn't say there's nothing there. It says, oh, it's high voltage there. It's
Correct.
High.
It's a high. It's a high input. And then when you push the button, it'll read a low.
Nice.
So that's what we're going to do. All right. Then we set up the serial port just like we did last time. We do our hello world, but I say O2 so that I make sure that we know that we're reading the second program that we've written. And then we've initialized some of the global scoped variables that we defined earlier. The last time, what the time was last time we went through this loop, and then what the state of the buttons was last time we went through the loop, whether the button was high or low. Remember, high means we are not pushing it, low means we are pushing it. Because we're going to use that later to detect when the button has been changed. Okay? So then we go into our loop. We are going to, at the top of our loop, we are going to get the current time and put it into a variable called this time. All right? So that says right now, this time we've gone through the loop, this is the time that it is. I am then going to take, so we haven't talked about the different formats that time can take. There are two different types of variables that time can be put in. One is called a time t, whoops, don't scroll. One is called a time t, and one of them is the TM elements that we saw last week, right? In this particular version of the code, we're going to want to use both of them. They each have their advantages and disadvantages. The time elements makes it very easy to pull out minutes, seconds, hours, and so on. But the time t is just a giant integer. It is the number of seconds since a given epoch. In Unix, time t is the number of seconds since, January 1st at midnight in 1970. It's just an arbitrary date, they said, and they're going to count seconds all the way up from there. That is very easy for things like, is this time greater than that time? Because then it's just a comparison of two different numbers. So I'm keeping time in both different variables to make it easier. In some cases I want to use one, in some cases I want to use the other. It does mean that we have to make sure to keep them in sync, and we'll see some code where I do that a little bit later. But for right now, just know that we're doing both.
Okay.
So we are reading it as a time t, and then we are creating elements from it. All right, and so now we have both of those. So again, here we are looking for an error from RTC get. If this time is equal 0, that means that RTC.get returned an error. It said something's wrong, I don't know what time it is, and we do our error checking just like we did last time.
Right.
Okay? And then if we did get an error, we return out of the loop and start the loop again. We don't do the rest of the processing. But if we did not get an error, then we have good time, so we continue on. So we are going to look for whether any of the time setting buttons have been pressed. Remember, I put a comment here to remember that high means it is not being pressed, low means that it is being pressed. So I'm going to define just a temporary variable that we're going to use. I'm going to do a digital read on the button, for the minute button. If, let's hear, button minute is the variable that holds what this value was last time.
Right.
So if before it was not being pressed,
and now it
is, that means that this time through the loop, someone has just pushed that button, all right? So we are going to do something. Button was open, now it's being pushed. So we are going to figure out what minute the time object thinks it is right now. We're going to add 1 to it. So we're going to increment it by 1. But if it was 59 before, we don't want it to read 60 now.
Right.
So we have to take modulo 60, 59 plus 1 equals 0, right? So this is the little bit of math that we're doing to set the variables. And then we're going to assign that back to the variable, and then we're going to set this tm.minute equals temp minute. Now, in theory, not even in theory, in reality, I could combine all 3 of these lines into a single line, but it's a little bit harder to understand.
Yeah, this is much easier for the people to actually figure out what's going on.
Exactly. And honestly, for a compiler, the compiler will optimize all of that into the exact same code, right? So there's no need to make your code overly complex to read, thinking that it will make the compiled code more optimized. It's not true. The compilers will optimize all of this out for you.
That's actually worth noting, because there are some people who think that your code gets uploaded into the Arduino. That actually doesn't happen. That's why you've got the IDE. That's the sketch you're making. Your sketch will be translated into something that actually can be uploaded to the Arduino. So yeah, as Mark was saying, write it in 1 line or 3 lines. The developer environment is going to turn it back into 1 line of code for the Arduino.
Yeah. The important part is to write it in a way that makes it easy for you to understand and for other people to understand, so that when you come back to this code 5 years from now and you've completely forgotten about all the things that you did, you can easily figure out what it was doing.
Right.
That's the most important part. All right, so let's keep going. So we have done that. And then once we have made that change, we have incremented the minute, we are going to then create a time t back from it using the makeTime function. And all of these functions, what was it? There was break time and make time. Those are both documented in the time library, which is one of the libraries that we installed last week when we were talking about the real-time clock. So break time and make time are from the time library. So we are going to take the time elements, which we just added we just changed, and we're going to create a time t back out of it. And then we are going to we're going to tell the RTC, this is your new time.
Okay, nice.
All right, so we have programmed the RTC with the new value.
We have to push it back out because
we have to push it back out. Otherwise, next time we read it,
it will go back to what it had.
It's just going to undo what it did.
There we go.
Right? And then we set button minute, which is the variable that we use to track whether the button has been pressed or not. We set it to the value that we just read.
There we go.
Okay, so it is now low, effectively, right? Then we go down and do the exact same thing for the button hour. So we're reading from a different pin, we're using a different state variable, we are setting this tm.hour instead of this tm.minute, and otherwise it's exactly the same code as right above it. Now we have set the time, we've looked at the buttons and we've set the time. Then if the time has changed since the last time we were through, and that's where we're using this time and last time.
Right.
Okay, so the last time was the global state variable, this time was the time that we got at the top of this loop, right? If those two are not the same, either because we've changed the time by hitting a button, or because the seconds have incremented,
right?
Since the time has changed from the RTC, then we want to set last time to this time, and then we want to output our time to the serial console, just like we did last time.
Right.
All right. So, and then we delay by 100, so it's 10 times a second.
And you would need this to guarantee that it's only going to update whenever there's actually a change, because otherwise, since this thing does loop 20 times a second, it would just keep going.
It would just print 10 times a second for every output. Right. So I only want it to update when it needs to update.
Exactly.
I am going to go ahead and upload that code to the Arduino. And this will work. Yay! So we got the time. I'm going to go ahead and push the minutes button. See how it's incrementing the minutes?
Nice.
All right, and then I will press the hours button.
And you actually see, this shows you a couple of different parts of the program. First is that it's updated only every second. So it's only updating when it changes. But also, when you push the button, it does change it. So you could make this output as many times as you can press it, even when it's not taking the tick.
Correct. In fact, it will output it every time I press the button, even if it's more than once a second.
Nice.
Because remember, the code says I'm going to change if you press a button, and then at the bottom below that, it's going to say if the time changed.
Right.
So every time you press the button, it will immediately trigger a new output.
Up to 20 times a second.
10.
Up to 10 times.
So it's delaying 100 milliseconds between each one.
Yeah, there we
go.
go.
10 times a second.
Okay, so now we know the buttons are working.
Now we know the buttons
actually
are working.
interacting with the code.
Correct.
Are we just limited to the screen? Can we push this elsewhere?
Yeah, let's
Figure that part out.
let's look out some meters.
Okay.
All right.
Meters.
Meters.
All right.
Analog panel meters. So this is an analog panel meter. It is a meter, it's right over here somewhere.
You've seen these.
You've seen these. They are, it's an electromagnet that's down here, and you pass a certain amount of current through that electromagnet, and it deflects this needle across here.
More current, more deflection.
More current, more deflection. Now you'll notice that this one is measuring volts, and the straight line means it's DC volts, and it's between 0 and 15. All right, so that means that this meter is configured to measure 15 volts DC full scale. But I just told you that that current, or that meter is measuring current. All analog panel meters are actually measuring current. And the way you configure a current device like this to measure voltage is by sticking a resistor in series with it.
If you actually want to see Smitty do the alterations to the meter so that it can measure current rather than voltage, go ahead and jump over to Know How. That's right, this is a cross-promotional series. He's going to be giving you exactly the step-by-step that you need to be able to take out a certain resistor and make sure that it's going to measure the current, which is what we can actually output from the Arduino. Now, Smitty,
Sure.
Having done that, we now have a meter that can be used with the Arduino, but we don't have a connection between the Arduino and the meter.
That's correct.
So how do we do that?
Well, so we had that resistor in there before, and that resistor was set up to read 15 volts. We can't get 15 volts, and we don't actually know. Some meters are 1 milliamp, some meters are 2 milliamps, some are 5, some are 100 microamps. They all vary. And so what we want is a circuit here that we can adjust to be able to put out the correct amount of current for the meter that we're using.
Oh,
okay.
okay.
So what I'm going to do is I'm going to use a 10 kilo ohm resistor, a potentiometer, a variable resistor here, and I'm going to put it into our breadboard. I'm going to kind of part these wires here. Remember that when you put these in, you want to put them in this way so that they are
So they're not shorted.
so
and
they're not
useless.
shorted. Yeah, if you put them in like this, then all 3 of the pins will be across in the same row. Each one of these row of holes is all connected to each other. And so if I want to be able to get to each of the pins, I need to put them in like that. So we are now looking at the third set of code. And so we pound defined the PWM pins. All right?
Okay, there they are.
There they are. So we are using 5, 6, and 9. I think I chose not to use 3 because it was kind of huddled between some of the other pins and soldering was going to make it more interesting. So we're going to use 5, 6, and 9. So I'm going to take a pin from 0, 1, 2, 3, 4, 5. Take that one there, put it into one side of the resistor. Was that for hour? That's hour. I'm going to go for seconds because it's easier to see. So I'm going to move that over to pin 9 where the seconds are. And then I've got that variable resistor in there. And then I've got this 1 meter that I already rigged up with some wires on the back. I just wrapped them around. And I'm going to hook this up to the output of the potentiometer and ground. Like that.
So this is the output that we see from the Arduino right now. We've just connected the meter, but we need to be able to calibrate it so that it shows us the right output. Can go ahead and show us what we're seeing on the meter. So what is this motion?
So you'll notice that the meter is changing ever so slowly.
slightly.
All right, so what it's doing is if we were to open this up and change the facing of this meter to read seconds, 0 through 60, then that's what the meter would be. It would be showing you what second is on display right now.
So at some point it's going to hit 60 seconds, go back to 0, and that meter should drop back down.
Correct. So, and we're doing this by sending an analog voltage. Now I have it going through the 10 kilo ohm potentiometer, and it's kind of unset right now, and
Right.
it happens to be in a good enough area that we can see it going up. I'm looking at the console, and we've got 20 more seconds before it kicks over, but it doesn't look like it's gonna make it all the way up in the time.
Yeah.
So
Well, I mean, what I really want is I want 0 to be 0 seconds. I want 300 to be 60 seconds.
Yeah, exactly. And so, nope, go back. And we're gonna get it right now. You'll notice how the needle just went back down, all right?
So I need a way to be able to calibrate this so that it will do the right range of motion. How do I do
Correct.
that?
So what we're going to do that is by adjusting this resistor here.
I'm changing the resistance because it is a potentiometer. Why does that allow me to calibrate?
So Ohm's law, remember? V equals IR. Voltage equals the current times resistance.
Right.
So I've got a certain voltage that comes out of the Arduino at full scale, right? So when the Arduino thinks I am pointing at 60, or actually 59, I'm pointing at 59 in 3 ticks is the absolute, because it doesn't point at 60, it goes back down to 0, right?
Right.
So when I'm pointing at 59 seconds and 3 ticks, that is full scale. You want that to be all the way over on the right-hand side of your dial. And so what we need is a way to tell the Arduino, give me full scale on my meter. And then what we're going to do is we're going to go in and adjust the potentiometer so that it is reading full scale.
Okay.
So once you go back over to the code for a second, Brian, I want to show the code that we used to do that. So we've added a few other things in here because I needed to be able to count ticks, quarters of a second. The real-time clock doesn't know about quarters of a second. So I am using the imprecise clock on the Arduino, counting the number of milliseconds that the Arduino thinks has passed.
Right.
Just to count 250 milliseconds, 500 milliseconds, 750 milliseconds, and then we reset at the top of each second. So there's some extra code in here to do all of that, which we can go over if we want. But otherwise, the code is very similar. Here's our setup. We have set up, I've added another button for the calibrate mode, which we're going to go into in a second. Serial ports and some other things. And then the loop, much of the same code, calibrate the meters. All right, so we're doing another thing. Digital read, if the calibrate button is low, that means we are pushing the calibrate button. What I'm going to do is I'm going to print out to the console calibration mode, adjust the potentiometer so that the needles read full scale.
Ah, okay.
Then I'm going to analog write an analog voltage of the maximum. PWM max is a pound define I defined earlier that defines what value is written at full scale. And so we're going to go ahead and analog write full scale out to all 3 of the meters. Okay? And then we're going to wait for the button to be released and then pushed again. And then when it is done being pushed, it will have been released, and then it completes the calibration mode and goes on with life.
We'll go through this code in more in depth in the next
Yes.
episode, but for now, let's go ahead and show them exactly how this works. So you have added this code, so it's looking for a key press.
Yep.
And when you do that key press, it goes below, it's going to allow you to set the values for max so you can calibrate that potentiometer to put the needle exactly where it needs to be.
Exactly.
All right, show us.
So I'm going to push this button, and it swings the needles over to full scale.
There we go.
Okay, so then we're going to take our screwdriver and we're going to adjust that potentiometer. That's a 25 turn, so it adjusts very slowly, which means you can get to it very precisely. And we're going to get that until right about there.
Boom.
Right there. That's full scale.
So when it is at its max current, it will be at the max level on the meter.
Exactly.
And when it goes to 0, it goes back to 0.
Exactly.
I like that.
So there's one other calibration point we need to do. If you remove power, the meter will go down to 0. Most meters come pretty well calibrated, but that one actually looks a little tiny bit off. There is a screw hole on the front. Let's see if I can do this without blocking the camera. And so you can physically adjust the 0 point
Nice.
down to actually 0, and I'm making it worse. Go the other direction. Right there.
Boom.
All right, so that's the 0 point. You want to adjust the 0 point first. We've got it powered back up. It is ticking. Let's press the calibrate button again. Now we need to recalibrate this because we changed.
calibrated at the low end.
Yep. And right there. That's full scale.
Fantastic.
We are now calibrated. You push the button to turn the calibration mode off, and it goes back.
Nice. We are going to show them the code that made all this possible in the next segment, but I'm afraid that's all the time we have for this week. Now, again, we have to tease them. So if you could tease the audience into what they'll be learning next week. Yeah, I think that's all the tease you're going to have to do. Now, thank you again, Mark Smith, for being our code warrior. It is always so much fun to talk to you because this is the programming I really get into because it is hardware and software at the same time. Could you please tell the folks at home where they can find you, where they can find your work, if they want to find out more about the things that you build?
So I mostly spend most of my time on Twitter at Smitty Halibut. I don't really have a blog or anything else. Most of my online life is spent on Twitter.
If you don't follow him on Twitter, it means that you hate life and a cat has died. Mark Smith, thank you again for coming on.
I can't be responsible for death to kitties.
Really can't. I can't.
No.
Back to you,
Padre.
Me. Thank you, Padre. And Padre and Smitty. Now, remember, if you are following along in this project, you need to watch Know How, episode 132. That's the one that we just did before the show, in order to find out how to mod the meter so that you can make it register properly. This is a crossover, folks, so you're going to want to watch Know How and Coding 101 to get the full experience of how you do the hardware and the software and to turn it into something magical. Now, speaking of something magical, if you are working on a project, if you've got a special passion that you want to get out to the world, well, you're going to need a place to put it on the internet. And we know it's all about location, 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 and about how you present that information, which is why we've got Squarespace as the second sponsor of this episode of Coding 101. Squarespace makes it easy for you to create a professional website, a blog, or an online store. They feature an elegant interface, beautiful templates, and incredible 24/7 customer support. I've used Squarespace a lot in the last few years because I deal with a lot of our institutions, our small churches and retreat centers and research centers that maybe don't have all the tech-savvy people. They've got plenty of content, plenty of things that they're passionate about, but they don't have a web programmer. Well, with Squarespace, you don't need that. You simply have to bring your ideas, your portfolio, your article, your blog, your whatever it is that you want to expose to the world, and Squarespace takes care of the rest. Now, here's why you're going to love Squarespace. It's simple, it's powerful, and it's beautiful. It makes changes easy because it does a preview, which means that you can see what changes to the content and to the code do in real time. No more of that switching back and forth between the coding screen and the preview screen. Squarespace understands that you learn best when you can see what happens with your actions. It's also easy to use, and if you want some help, Squarespace has live chat and email support 24 hours a day, 7 days a week. Now, you might think that this is going to break the bank with all these features, with all these templates, with something that looks this beautiful, it's going to cost an arm and a leg. And no, not at all. It starts at $8 a month. And they take care of hosting so that you don't have to. Plus, if you buy Squarespace for a year, you get your domain name for free. All Squarespace websites are responsive, and they scale to look great on any device. It means it's never going to go down. It means that it's going to look as good on a laptop as it does on a desktop, as it does on a mobile phone, as it does on a tablet. All that code is taken care of. But if you want to deal with the code, they've got a developer environment so that you can get in there and tinker. Now, e-commerce is available, which means that every website comes with a free online store. And now with Cover Pages, a brand new feature in Squarespace 7, you can set up a beautiful one-page online presence in minutes, literally in minutes. It's perfect for creating quick landing pages for your brand, personal identity, or to promote a new product. Folks, if you've watched Twit TV at all, you know that we love Squarespace. It takes something that's so easy, it turns it into something that's so beautiful, and it just makes it a place for you to get your ideas out to the people who need to hear them. We want you to start right now, today. Go ahead and sign up. You can start a trial with no credit card required and build your website instantly. When you sign up for Squarespace, make sure to use the offer code C101 to get 10% off your first purchase and to show some love for Coding 101. We thank Squarespace for their support of Coding 101. Squarespace, build it beautiful. And we thank Squarespace for their support of Coding 101. Now, Lou, next week is going to be the last episode we do with this embedded programming module. One of the things that I'm not sure if all of our audience knows, when you do Arduino programming, it's really just C, right?
Exactly. Really easy C.
Yeah, exactly. So if you've done any sort of programming in C or any of the C frameworks, Arduino programming is really not anything new. In fact, it uses all of the same components that you've seen in the modules here on Coding 101, loops and variables and if-then statements. So go ahead and give it a try. It's really, really, really hard to break an Arduino project. Pretty much the only way you could do it is if you physically break the board. Go ahead, upload bad code, upload horrible code, upload whatever it is that your mind is thinking of. And don't forget that you can always get all of the code snippets that we use in our episodes at our show page and alter them. See what you can come up with. Lou, anything you want to add before we send the audience off to do their homework?
No, I think like you said, I mean, the really easy C. Check out some of the C programming that's out there. We just talked about Strux in the beginning of the show, and I think there's some really great articles and some good blog posts out there about it, and it'll get you going on just normal C style programming too. So Arduino is a great example of kind of implementing your own project and getting you out there and trying new things.
Lou Maresca, again, our super special guest co-host, formerly a code warrior here on Coding 101. We want to thank you for coming back. Could you please tell our audience where they can find you and your work?
Absolutely. So I'm LouMM, L-O-U-M-M at Twitter, and also about me. And you can find all my work, my daily work that I do at crm.dynamics.com.
And we've seen you on This Week in Enterprise Tech. We've seen you on Coding 101. We've seen you on some of our news programs. And my understanding is that we're going to start seeing you do reviews for Before You Buy. Is there any truth to that rumor?
Yeah, I'm super excited about that. I get to play with toys.
Lou Maresca, folks. Follow him. See what he's doing. He's a good guy. Now, speaking of good guys, we want to do something for all of you good guys and gals and geeks out there. We want to give you a place where you can get all of our episodes and all of our show notes in one easy place. All you got to do is go to our show page at twit.tv/code. If you go there, you'll be able to find all of our back episodes. So if you want to catch up, go ahead and download full audio versions or video versions, whatever you need, so that you can follow along with our C modules or our Perl module or our PHP module or now our Arduino module. Now, this is also a really good place for you to download the actual code snippets. There'll be links there so that you can get the programming. Why have to reprogram everything that we do or try to copy from the screen? Just download it, get it onto your modules, and see what it does. Also, don't forget that you can find this on Google+. In fact, this is a great place to go. We've got almost 2,000 members of this community, and it has people like Joe Hecht and experts and intermediate folk and newbies. It's a place to go if you ever want to ask questions or if you want to answer a couple of questions. You know, coding is best when you do it in a community, and that's what Google+ is for us. Also, don't forget that you can find me on Twitter. That's right. Just go to twitter.com/PadreSJ. That's at PadreSJ. If you follow me there, you'll see the sign up for Twitter screen, but then you'll see what I do during the week, even when I'm not on Twit TV. Not only will you find out when I'm flying my quadcopters, but you'll see the next episodes and topics for Coding 101, or for Know-How, or for This Week in Enterprise Tech, or for Padre's Corner, or for Before You Buy. Speaking of that, quick reminder, this will be the last episode of Coding 101 on Thursdays. We're now going to be moving the show to Fridays at 2:30 p.m. Pacific time. So if you need to change your calendar, make sure you do that. We're still going to be giving you everything in the show notes, and everything will stay the same, and we're going to be running the show the same way. We just wanted to give a bit more time to some of the other shows that we do here on Twit TV, and it made sense for me to have that show on Monday. Speaking of people who make things work here, there's a man who pushes the buttons, a man who I value a lot, and I want him to say a couple of words. Cranky Hippo, where can the Twit TV Army find you?
Oh, me, Padre?
Wow.
Yeah. You can follow me on Twitter. Sorry. I had to wear them. These lights are crazy bright over here. Yeah, on Thursdays we have a lot of fun doing Know-How. So, like, just a little bit earlier today we were doing some fun stuff. And, you know, I do BYB stuff, so I guess we'll be doing that together some more too. But I'm also taking a C++ class, so this is becoming a more and more interesting show for me because I can kind of wrap my head around it now. But for those of you out there wondering what else I do here at Twit, you can follow me at cranky_hippo on Twitter. And our Instamorph thing that Patrick did on Know-How was pretty cool. So
very cool.
Check that out if you haven't. Back to you, Padre.
I also understand that we've had people posting in the Google Plus community what look like homework assignments. That's not you, is it?
No, of course not. No, there's just a lot of questions out there, Padre. But if you do answer those homework questions, could you put comments in there and just fill it out? You know, don't want the teacher to get suspicious or anything.
Oh, and by the way, make sure that you use the initials B. BB.
Please sign all your work, Brian Burnett or Cranky Hippo. Either one is fine.
Thank you very much. Folks, thank you for joining us here for Coding 101. We'll see you next time on Monday at 2:30. Until then, I'm Father Robert Ballecer. End of line.